Hi guys, this is Mrs. Allison. Today we're going to look a little bit at particle motion in terms of calculus. Probably you saw this last year in trig pre-calc and you probably saw these concepts for those of you that took physics in Algebra 1 or as freshmen saw it then too. But let's put it in terms of calculus today, shall we? Particle motion describes the motion of an object that moves along a line. There are three functions that we're going to use to model particle motion. The first is our position function. Now, what I want to do is I want to give you what a position function is, its units, and how we will typically see it notated. So position is the location. Where is the particle specifically? And the units that we typically use, you will see either meters or feet, but really that part's less relevant, just knowing that it is a location. Now, as far as a way to describe it, a variable to describe it, we would describe this as x of t is our position function, but you may also see it as s of t. That also represents position function, but essentially it's just some variable with respect to t. It represents our position function, t being our time. Now, time is usually in seconds, but obviously that could change, just like meters or feet. Okay, so if we were to define velocity, how would we define velocity? Well, if I were to define velocity, I would say it's the speed, but more specifically than just speed, it's speed in a direction. Velocity is signed. Be positive or negative signs, and that positive or negative sign determines the direction. Now, we might also consider this the rate of change of the position. Okay, so units that we would see, if we're using meters, we would have meters per second, or if we're using feet, we would have feet per second. That's how you know you're using velocity, is when you see those units of meters per second, feet per second, whatever the increment position was per second. Now, to notate velocity, we know that velocity is written as v of t. But what is v of t equivalent to in relationship to the position? Well, the velocity is the derivative of the position. So you might also see this as x prime of t. All right, so then what is acceleration? How is it different? Well, the acceleration is the rate of change of the velocity. Rate of change of the velocity. And that pretty much describes the whole piece of information that we need to know about acceleration, because if we were to write our function notation, acceleration is a of t, but if it's the rate of change of velocity, it's the derivative of the velocity. But if it's the derivative of the velocity, it means it's the second derivative of my position. Now, we can tell we're talking about acceleration just by looking at the units, because the units here will be meters per second squared, or feet per second squared if that's what we're using. Hopefully we feel pretty confident with those. Now let's take a look at, so let's talk about speed first. Anybody know how to find speed? Well, speed is the absolute value of the velocity. The absolute value of the velocity. Because it doesn't matter what direction we're going, speed is always going to be a positive number. Even if you're going backwards, the speed is still speed, so it has to be positive whether you're going forward or backwards. The next thing we need to talk about is displacement, because this is a vocab word that is used a lot. Displacement. Displacement is the net change in position from the starting point. Now, this is different than total distance, and we'll look at that in just a second. Total distance is the distance that takes into account all direction changes. I'm just going to put takes into account all direction changes. So let me give you an example of displacement versus total distance. If we had a number line, let's just draw one here. If I have a number line, and let's say I'm starting at 0, and I move my person 3 to the right, and then 5 to the left. So here is where my person ends up. This was 0. Okay, if I started here 0 and I went 3 to the right and then 5 to the left, my displacement is -2, but my total position is 5. Or my total, sorry, not position, my total distance is 5. I've traveled 5 units. Okay, that's the difference between displacement and total distance. All right, let's look at some examples. What I would love for you to do is hit pause and try these with your C partner and see what you get with these 1, 2, 3, 4, 5, 6 topics. All right, let's take a look at these. Going through here, using the position function, x of t equals 16t cubed minus 36t squared plus 24, an object moving on a horizontal line. Distance units are measured in feet and time is in seconds. So here we go. What is the initial position? Hopefully you know initial position is when time is 0. So we're going to use the position function and plug in 0, which when we plug that in, we would get 0 minus 0 plus 24. So we get 24, and they said the units are feet. AP likes its units, so be sure to put your units there. It doesn't need to carry it all the way through all the problems, just on the answers is fine. What is the velocity of the object at t equals 1 second? What should I do? I should take the velocity or find the velocity, which means I'm taking the derivative. So we would get 48t squared minus 72t. And then I'm going to plug in 1. And I get that the velocity is -24, and the units here would be feet per second. Now, is it okay that it's negative? Sure, because remember, velocity is speed in a direction. So this direction is going backwards or to the left at this point. Then it says, what is the speed of the object at time t equals 1 second? Well, we've already done all the work for this because the velocity at t equals 1, or the speed, is just the absolute value of the velocity at 1, which means my speed is 24 feet per second. What is the acceleration of the object at time t equals 1 second? Well, again, to get the acceleration, we would need to take the derivative, and then we would need to substitute in 1. So we get 96 times 1 minus 72, or 24, apparently that was a theme, 24 feet per second squared. Okay, I would like you to put a star by this question, or at least file it away in your memory, because this question is asked often. Is the object speeding up or slowing down at time t equals 1 second? And how do you know? If you were asked to justify this, how would you do that? Well, I'm going to tell you the answer is slowing down. Why? Well, the reason it is slowing down is because we are moving to the left at 24 feet per second, but my acceleration is in the positive direction, so these two forces are working against each other. Basically, if my signs don't match, if my signs of my velocity and acceleration do not match, then it's slowing down. So I'm going to go ahead and notate that really quick, because the velocity and acceleration signs do not match. Okay. So on here, I have put the 2 times we would consider a particle to be speeding up would be when the velocity is greater than 0 and the acceleration is greater than 0 at the same time, or when the velocity is less than 0 and the acceleration is also less than 0. If the signs don't match, meaning the velocity is greater than 0 but the acceleration is less than 0, or the velocity is less than 0 and the acceleration is greater than 0, the particle will be slowing down. I would maybe make note of that somewhere or just file it away at this point to keep there. So when is the object at rest? That's a tricky question. What does it mean to be at rest? Well, it means we're not moving anywhere. We don't have any speed in any direction, which when we see this phrase at rest, it means that I'm looking for where my velocity is 0. So I'm going to set 0 equal to 48t squared minus 72t, and I'm going to do some math on that. And I get t equals 0 and t equals 3/2. Well, obviously the particle was at rest. Its time equals 0 in this particular example. But time t equals 3/2 is also, the particle is also at rest. All right, if you turn the page over, you'll notice that there are 4 more problems that go with this same setup. So I would like you to hit pause and try those 4, and we'll come back. Okay, first question says, when is the object moving right? What would that mean? Well, that would mean when the velocity is greater than 0. We would want here to be moving right. We want the velocity to be greater than 0. Well, we already have these 2 values that we found before where it was at rest. That's where it's changing, or could potentially be changing from going left and going right. So if we were to look at a number line, assuming that time is not going to be less than 0, here is the intervals that create my time frame for this particle moving. Okay, so how do I consider where the velocity is going to be positive or where it's going to be greater than 0? Well, I would need to test a value in here, in this region between 0 and 3/2, and I would need to test a value in a region greater than 3/2. So I can plug in any number. So maybe I plug in something like t equals 1 or t equals 2 into my velocity equation and look to see whether it's positive or negative. Okay, so I want my velocity to be greater than 0. And when I plug in t equals 1, I don't actually care what the number is, but it's negative. And when I plug in t equals 2, I get a positive number. Therefore, when t is greater than 3/2, we know that the particle is moving to the right. Now, you could also see this written this way in interval notation as opposed to inequality notation. So 3/2 to infinity, that also works. So, since we've already done all the work, when's the object moving left? Right, it's moving left when t is between 0 and 3/2, or in interval notation, would look like this. Okay, what is the displacement of the object between t equals 0 and t equals 2 seconds? Well, remember, displacement is how far away it moved from where it started. So I need to figure out the position at 0 and the position at 2 so that I can figure out how far it's moved. And the position at 0 is 24, and the position at 2 is 8. So if I start at 24 feet, in this case, and I end at 8 feet, what happened? My displacement is negative 16 feet. I went from 24 to 8, so I had to go down 16 feet to get there. Now, if we want to figure out the total distance traveled, I have to think about it a little bit differently. I have to take into account when the object changed directions, because that matters. So I need to consider not just the point x of 0 and x of 2, which we already know. I also need to consider what happens when it changes direction when t equals 3/2. So if I plug in 3/2 into my equation, I get -3. And the distance between 24 and -3 is 27. And the distance between -3 and 8 is 11. In this case, the units are feet. So my total distance traveled is 38 feet. How'd you do? Okay, hit pause and try example 2. Let's talk about what a graph might look like when we're dealing with position, velocity, and acceleration. All right, one of the biggest things that you can pay attention to when you are taking an AP exam is what they're giving you the graph of. Make sure you know, because sometimes if you don't read the full question, if you don't look at the graph, you assume what the graph is asking, and it's not actually asking what you think it's asking. So be careful. So a couple things I notice. In this problem, it says the graph shows the position function, which means this graph is a position function. So every dot that I see represents the position at A, the position at B, the position at C at a given time. That's important. Okay, was the car going faster at A or B, and why? Well, the car was going faster at B. Why? Because if we look at the slope of B, the slope of the tangent at B versus the slope of the tangent at A, it's much faster. And we know that we deal with speed with the velocity, which is the slope of the position. When was the car stopped? Hopefully you said from C to D here, because it is a horizontal line. Then it asks, at which point was the car's velocity the greatest? Now keep in mind, it's talking about velocity, not speed, because this is a very different question. You've got two different questions. C is velocity, D is speed. So at what point is the car's velocity the greatest? Meaning the highest positive number. Hopefully you said B. And then when is the car's speed the greatest? Well, remember, speed is based off of the absolute value of velocity, which means I'm just looking for the biggest number, whether it's positive or negative. And in this case, I would say the speed's greatest at E. All right, hopefully that's enough of a review of particle motion, or enough of a intro to particle motion if you've never seen it before. So I hope you have a great day, and we'll talk soon.